Hi everyone! Previously we studied either and realized that the API is very convenient for short-circuiting a function when an error occurs. However, if we want to accumulate errors in order to report everything that went wrong, then either is not really fit for the task. That's why functional libraries such as cat or ZeoPrelude have created an error type dedicated for this use case, called validation. In this lesson, we'll define it ourselves since it is fairly straightforward, but you can find a link to these FP libraries below the video. A validation is an enumeration with two covariant type parameters, E and A. As you can see, a validation is almost identical to either, except for a few points. Right is called valid, left is called invalid, and invalid stores a list of errors instead of a single value. This last point is the most important one. This is what allows validation to store multiple errors. For example, if we adapt validate user to validation, we would expect to get a valid result if both inputs are correct, an invalid result with one element if one field is incorrect, and an invalid result with two elements if both the username and country of residence are incorrect. Now, there is one issue with this encoding of validation. List may not be the best data structure to store the errors, because lists can be empty, and it wouldn't make sense to get an invalid result with an empty list. It would mean that the result is wrong, but we don't know why. So ideally, we would like to use a data structure that contains at least one element. Unfortunately, there is no such data structure in the Scala standard library, at least not yet. But many third-party libraries have one. It is often called non-empty list, or NEL for short. A non-empty list is simply a case class containing one element and a list of additional elements. So we have the guarantee that there is at least one item in this data structure. Non-empty list also comes with a familiar API. For example, we can use nel.apply to create a non-empty list, or we can prepend, append, or even select element with filter. Note that append and prepend returns a nel, but filters returns a list. This is because filter doesn't guarantee that there will be at least one element satisfying the predicate. For example, there is no number bigger than 10 in this non-empty list. Cool, so now that we have access to nel, we can use it inside validation. We'll say that the invalid constructor contains a non-empty list of errors. Now let's open the file validation exercises, located in the package exercises.errorhandling.validation. First, we're going to re-implement the function validateCountry, but this time it will return a validation instead of an either. So if you want, you can copy-paste the implementation from either exercises2 and adapt the code. Note that you can find a few helper methods in the companion object of validation. For example, these are helper methods to create a validation object. And there are also some syntax functions, some extension function in the file package.scala, located in the same package. So please pause the video and try to re-implement validateCountry with validation. Okay, so let's start by copy-pasting the code from either exercises2. By the way, I forgot to mention, but I also changed the name of the error. Before it used to be called validation error, and in this exercise I called it form error, because I think form error is probably a better name for this because we are validating a form, like a web form, but also it will avoid confusion between validation and validation error. Okay, so we can copy-paste this code, and now we need to adapt it from either to validation. So now the first thing that this code does, it's an if then else, so it checks if the format is valid, and if it is not valid, we return an invalid format. Before we used to put it inside the left, now we need to use invalid instead. The problem is that invalid takes a non-empty list of errors. So if we want to use invalid, we need to say invalid of nel, like this. So it means it's a bit more annoying to create invalid values with validations, especially when there is only one. Now that's why there are a few helper methods inside of the validation object to help us to do so. So we can say validation.invalid, and if we do this, it will create, so as you can see, this invalid function takes one value plus a var arg, so this is like as many arguments as we want, and it's going to build the invalid object for us. So this will, if we pass only one value, it will create a non-empty list with one value. If we specify many values, it will just create a non-empty list with all these values. So it's quite convenient. Another thing we could have done is to use an extension method. We could have said invalid format dot invalid, and it would have done the same thing. I quite like this syntax because I like this kind of OOP syntax when we just do dot, 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 dot and keep adding stuff to it. Okay, so now let's work on this branch of the if then else. So here, the first thing we do is that we try to look up a country code that matches the one we want. So we're trying to find a country that matches the country code passed as input. And so this will return an option. And if the option is none, we'll return a left using toRight, and if the option is some, we'll convert it into a right. So toRight is in charge of doing this conversion from option to either. And there is a similar function for validation. We can say toValid, and toValid will say, okay, if the option is none, we'll specify which error we want, and it will create an invalid value for this. And if the option is some, it will wrap it inside with valid. So really the same thing as toRight, but for validation. Okay, now let's verify that we have implemented it correctly. Let's run the test. Yeah, it works, nice. Now let's go back to validation exercises, and we're going to repeat the same process for check username size and check username characters. So please copy-paste the code from either exercises 2 and adapt it to validation. The goal of these exercises is really to get familiar with the validation API. Okay, so let's start with check username size. We can copy-paste the implementation from either exercises 2, which used either.cond. So either.cond is a function that takes 3 parameters, a predicate, and one value if the predicate is true, one value if the predicate is false. So there must be a similar function in the companion object of validation. And indeed, there is a validation.cond that does exactly this, except that the parameters are called success and failure instead of left and right. So this means that we can very easily adapt the code. We'll just say validation.cond, and instead of right, we'll say valid, and instead of right, we'll say success, and instead of left, we'll say failure. Yep. Let's try to run the test. So we'll enable check username size and run it. All good? So we'll redo the same thing for check username characters. We copy-paste it from either exercises 2. So this function, what it did, what it does is that it first tries to find out if there is any invalid characters inside of the username. If there is no invalid characters, then it returns a right, so success. And if there are some invalid characters, then it returns a left. So what we can do here is that we can simply change right by valid. It will work. Or we can use the suffix function, so the extension function, to say unit.valid. That's my favorite one, but it's really up to you. And in case it's an invalid characters, we'll replace left by .invalid. So fairly straightforward. Now, one thing to think about here is that invalid characters, as you can see, it takes a list of characters, but it doesn't make too much sense because this enumeration, this case class, is supposed to represent the case where there are some invalid characters inside the username. But a list is not really the good data structure. Here we should probably use also a non-empty list because when there are invalid characters, there must be at least one. It wouldn't make sense to get an invalid characters with an empty list. So if you want as a bonus exercise, I will let you refactor invalid characters to use non-empty list instead. Okay, so far there is not much difference between either and validation, because the functions we implemented are only producing one error each. Now this is going to change next. We are going to re-implement the function validate username so that it combines both check username size and check username content. However, this time around, we expect to get two form errors if the username is both too short and contain invalid characters. I encourage you to try using a for comprehension and other methods of the validation API, such as zip and zipwith. So please pause the video and give it a shot. Okay, so I suggest that we start by using a for comprehension, because so far this was the best tool we have to combine things one after another. So what we want to do is to call check username size and check username characters one after another, and if both of them are valid, then we know that the username is valid, so we can construct it. So I say username. So this means that we don't really care about the return type of check username size and check username characters, because on the valid part of the validation it's unit, so it's meaningless. We just call these functions in order to verify if they are invalid or not. And if both of them are valid, we will build a username at the end. Okay, so let's run the test. Let's enable validate username, and let's verify if it works. It doesn't. So let's check what does it say. So it is in this case, so in the last one, so the first three cases worked, but the last one didn't. So the last one we called it with an exclamation mark, and we expected to get a non-empty list with too small and invalid characters with this exclamation mark. Now instead we only got one error, so this is what we got, this is what we expected. Instead we only got one error with too small. So we didn't get the invalid characters part. Now if you think about it, it kind of makes sense because we used a for comprehension to implement validate username. And a for comprehension, we know that it is by nature sequential. We execute one line after another, and the second line is only executed if the first one succeeds, because we do have access to the result of the first one. So this means that this function here is only going to be called if the first one is successful. So even though we build validation to accumulate errors, when we use it with a for comprehension, it is short-circuiting. So it behaves in the same way as either and option and everything else. Like a for comprehension is always like that. There is no way around. This is in fact why the CATS FP libraries doesn't provide a method flatmap for validation, because they're probably afraid that users who don't really know much about validation may start to use their favorite tool, the for comprehension, to build a validation, and in this case it's not going to accumulate. So I think in CATS they have another method called endden that do the same as flatmap, but it has a different name so that you can't use a for comprehension to build a validation. So I'm not sure if it's a great design, but I believe that this is the idea they had when they implemented validation in CATS. Okay, so this means that at least for us, it means that we need to use a different function if we want to accumulate, to combine validations together and accumulate the errors. So let's have a look at the function zip and zipwith in validation. So as you can see, zip, it's not yet implemented, but it says in the definition that it is supposed to accumulate errors in case both are invalid. So this must be the function we need. So as you can see, zip takes another validation which has different errors and different values, and it's going to produce a validation which has a tuple of A. A is the value, is the type of the current validation, and other is the type of the second validation. And as you can see, we use the same trick that we've seen in the variance video, where we define a type E2, which is a parent of E, and this is really used to basically get the type inference works as expected. So even though it looks scary, don't worry too much about this, it does the right thing. So really the important part is that we want to combine these two validations together, and we need to basically consider all the possible scenarios, if it is valid and invalid, valid, valid, invalid, invalid. So I'll let you pause the video and try to implement zip. And once you have done it, can you please try to use zip to re-implement validate username? Okay, so let's do this. We're going to start by doing a pattern match based on the current validation and the other validation. So we can pattern match on two values together, which we simply need to put them in a tuple. So we can say zip, this and other are put in a tuple, and then we can pattern match on this. The only thing annoying is when you do pattern match on a tuple like this, at least IntelliJ doesn't provide this exhaustive pattern match out of the box. So it means that we have to do it manually. So okay, so there are four cases. There is the one where it's valid, so let's say it's A, and the second one is other. So this is the first case, basically the happy case where everything is good. So let's write the four cases and then we'll do the implementation. So second case is where the first one is valid and the second one is invalid. So let's call ES for errors. Then we reverse it when we say the first one is invalid and the second one is valid. And then the last case where both of them are invalid. So let's give it ES1 for errors 1 and ES2 for errors 2. Okay? So now we have the four cases defined. So this means that our pattern match is exhaustive. So what do we want to do in case both of them are valid? So if both of them are valid, then this is the only case where the result is valid. So in this case, we're going to return a valid, and we're going to put A and other, we're going to put the two values inside of a tuple. Yeah? So the second case is if one is valid and the other one is invalid. So this is this case here when we have one valid and one invalid. We do expect to get one invalid back with all the errors from the second one. So basically we're going to construct invalid with ES. Yeah. So actually we can use an underscore here because we don't care about the valid result, the content of the valid result. Because there is at least one invalid result, this is going to be what we return at the end. It's going to be the same here, except that this one is the first one that is invalid and the second one that is valid. So in fact, if you look at this, these first three cases are exactly the same with either. If you replace valid by right and invalid by left, this will be the same code as either. Now, the real difference is here, when both of them are invalid. If we were working with either, we would have returned the first one. So if you want, we would have short-circuited. We would not even have considered the second one because the first one is invalid. While the real difference with either is that we're going to concatenate the two errors. So we're going to say the two validations are invalid, so we're going to return an invalid where we put the two errors together. Okay, so let's run the test to verify that zip is working properly. Oh, it seems that I didn't actually wrote a test file for validation. So please, can you do this as a bonus exercise? And for now, what we're going to do is that we're going to try to update validate username using zip. This way, at least, this will be one way to test that zip is working correctly. We do expect that if we use zip in validate username, it should accumulate errors. So please pause the video and try to refactor validate username. Okay, so basically what we want to do is that instead of a for comprehension, we want to zip all the validations. So we're going to do this. And this is going to return a validation where on the right-hand side there is a tuple. So this means that we can map over it and pattern match on this tuple. So this will be, actually we don't really care. We could very well say underscore, because we know that this tuple is just unit. That doesn't make any sense. It doesn't bring us any data. So we can say username here, like this. So this really means, please do this validation, then do this validation. If both of them is valid, we are going to call map and we'll create the username. Let's give it a try. Yes, so now the test passed. Now, if we do call validate username with an exclamation mark, we do get two different errors, exactly as we wanted. One refactoring we can do also here is that here it's kind of okay when there is only two cases, but if there were more, like you could imagine, maybe you have 3, you have 4, 5 different validations that you want to combine, it's not really convenient to zip many times because you're going to create kind of a nested tuple at the end. So that's why generally FP libraries, what they do is that they create lots of boilerplate for us. So for example, you could put all your validation within a tuple, and then at the end, you can say zip. And if you want, if you look at the extension method, there is an extension method for a tuple with 2 validations, and there is another extension method for a tuple with 3 validations. So this kind of code is very, very boilerplatey. We never want to write it ourselves, but it's very convenient to use as an end user. So this is why, this is one of the main benefits of using these third-party libraries. They provide all these convenient methods that we really don't want to write ourselves. Now, one last thing I would like to show you is that it's actually quite common to say zip followed by map, because generally we don't really want to return a tuple at the end. We more want to transform this tuple into something else. So that's why there is a method called zipWiz that basically does the same thing. So zipWiz does map plus zip together, except that zipWiz is going to return a function that takes 2 parameters. So before, we had a function that takes, when you say with map, we had a function with 1 parameter, and the 1 parameter was a tuple. Here, it's one function that has 2 parameters. That's why we slightly need to change the syntax here. We need to actually say parentheses and with 2 underscores to mean that here in this case we don't really care about each input. So this is a bit annoying with a syntax change, but otherwise zipWiz is the same as zip followed by map. Let's run the test to just verify that we haven't broken anything. Yeah, nice. I can actually just refactor it like this. Might be more readable. Finally, in the last and most important exercise for today, we are going to validate both the username and country of residence together. If both inputs are wrong, we expect to see all the errors in the result. So I'll let you pause the video and give it a try. Okay, so we know that we can't use a for comprehension for this function, because if we do, it will short-circuit the evaluation of the validation, and we'll only get the first errors that happen. If we want to accumulate the errors, we need to use zip or zipWiz, exactly as we've done before. So let's give it a try. First, we're going to call validate username. We'll pass the username string as parameter. And then we'll call validate country with the country of residence string. Now this gives us a tuple with 2 validations inside it. This means that we can call zip or zipWiz. So zipWiz is actually more convenient. And zipWiz will give us 2 arguments, the username and the country. So if you want this function that is passed as argument of zipWiz is only going to be called if every single validation within the tuple are valid. So if you want, we only care about the happy path within this inner function. And if there is any error, so anything invalid within the tuple, then zipWiz will be in charge of returning an invalid result for us. So it's very convenient. So here we'll say this is the first input, this is the second input, and what do we do with this username and country? We're going to create a user class passing the username and country of residence as input. As simple as that. Let's run the test to see if it works. So we'll enable it and run it. Yeah, it works, nice. Just a quick refactoring I would like to show you is that here we are defining the inputs, so username and country, and we use them only once in the same order. So if you want, this is a very particular case where we can actually use a val function as parameter. So here we could say, instead of defining the argument and using them straight away in the same order, we could say username.apply. So username.apply is the constructor function, the function that creates a user passing every single parameters in the right order. So if you want, this is a specific use case that is actually quite readable here. Now, there is still one problem with validate user. It's the fact that we don't know which field caused an error. For example, when we get an invalid result with a value of type too small, how do we know that this too small corresponds to the username and not the country of residence? The only way to find out is actually to read the code carefully and check out that too small is only produced in the username logic. So it's not really convenient. At the moment, it's not too difficult because there are only 2 fields, but it will be much more complex if we had a longer form to validate. One way to fix this issue is to update all the error classes so that they include the name of the field that caused an error. Or we can use a new error type called field error. So a field error contains two fields, a field ID that corresponds to the HTML ID of the input, and errors, a non-empty list of form errors for this particular field. For example, if we call validate user with B exclamation mark as a username and UK as a country of residence, we expect to get an invalid result containing one field error for the username, which contains two form errors, too small and invalid characters, and one field error for the country of residence, which contains only one error of type invalid format. Great, so let you pause the video and try to refactor validate user so that it uses field error in the error type instead of form error. You may want to use the method map error or map error all from the validation class. Okay, so let's start by changing the return type of validate user. So instead of using form error, we want to use field error. So let's do this. Now, most likely, we still want to validate every single field and zip it at the end with user.apply. This means that what we want to change is every single line within this tuple, so that at the moment they use a form error and we want to transform it to a field error. So maybe what we could do is maybe create a helper method, like let's call it field, maybe there is a better name for this, where it's going to take a validation, and it's going to be a validation of what? It's going to be a validation of form error A, because we don't really care about what is the result at the end. And it's going to produce a validation of field error A. So if we had such a function, we could call it here. We could say field and field here. And this will transform the error of both functions to the appropriate type, and then we'll zip it together. So really the only complex thing is to implement this function. Okay, so validation is an enumeration. So we could very well say validation match, and then say, okay, if the validation is valid, we return the same thing. And if the validation is invalid, what do we do? So this is a list of errors. So this is like, it's called form errors. So in case it is invalid, we still want to return invalid. We don't want to change the validity. It's still going to be invalid. But we're going to change the error type. We want to use field error instead. So if you want, here we're going to say is that we're going to return a field error, field error, but this needs to be a null. So actually it might be more useful to say, okay, form errors something, something, and use two invalid at the end. This way we don't have to wrap it in a non-empty list. Okay, so here, what do we do? So here is the form errors. So we want to store the form errors within the field error. And the first parameter here corresponds to a field ID. So the field ID is supposed to represent the HTML ID for this particular invalid input. Why do we return this? Is that it might be useful for the front end. So maybe the front end, they send us a form, like the content of a form, and we want to return an error that will give them exactly the ID of the invalid field, so that they can probably add some kind of text next to the field. Okay, so here, in this case, we want to pass username or country of residence, this is going to change based on each function. For this one, it's going to be username. For this one, it's going to be country of residence. So this means that we need to pass an extra parameter here that describes the field ID. So we say field ID string, and we'll do it like that. Okay? So now we need to change the definition of our function. So here we need to pass the field ID. So here we could copy paste, say, username and country of residence. But I generally don't like to pass to hard-code string like that, because most likely there will be several places in our code base where we have them. So ideally the best would be to use a custom enumeration, but it might be a bit overkill. So if you really want to have like a cheaper way of creating custom enumeration, you can create an object class. That's what I've done here. And here I listed the strings that we care about. So if you want here, instead of doing username, we can say field.username, fieldids.username, and here we say fieldid.country of residence. It's not as good as a custom enumeration, but it's a bit faster to create. So it's really a trade-off. Okay, so let's give it a try. Well, actually, before we run the test, we need to update them because at the moment they were returning form errors, so it doesn't even compile. So in the case where it's valid, it doesn't change anything. In the case where this is invalid, so what we're going to return is, so it's going to be a bit more complex. It's going to be a field error. This field error will contain a non-empty list of this invalid format. And here we need to specify which field is invalid. So which field is invalid at the moment is the country of residence. So we'll need to say fieldids.country of residence. If we want to make it even shorter, we may want to import all the field IDs like that. This is just a way to make our test a little bit more readable. Okay, so we're going to do the same for the next test. So let's copy paste this. Now, what is invalid in this test is the username. The username is too small, so we'll say username. And the instead of invalid format is too small. So too small of 2. Okay, so far it's a bit more painful, but it's also a bit more precise. Now this is very the interesting case where we do had some errors about the username and some errors about the country of residence. So this is where hopefully this things pays off. So now what we need is to create a non-empty list. Maybe this, let's try to be, maybe let's be explicit here. So we'll say an invalid with non-empty list. Okay, and what are the errors inside of this invalid? So the first one is a field error about the username, and the second one is going to be a field error about the country of residence. Okay? So how the username is invalid, so what was it before? It was because it's too small. Yeah, it is too small. It's only 2 characters. And this one is invalid because it's an invalid format. And oh, yeah, I forgot. The username is also invalid because there are some invalid characters. So this is, I was wrong. This invalid characters is about the username, not the country of residence. So we'll do something like this. Do I have something wrong? Yep. Okay. So you see, it's much more complex to create. I mean, at least to create in our test. But it perfectly describes what happens. And that's what matters. You know, or hopefully, it will be much easier to process this kind of information. So let's run the test to see if we have done it correctly. Yeah, nice. It works for the first time. Cool. So just one quick refactoring I would like to show you before we finish. We wrap things up. Here, this function, if you want, is very similar to map, except that instead of transforming the valid, normally map transforms the valid side and doesn't touch the invalid. This function is very similar to mapping, but for the invalid. So we could have implemented using one of the map errors functions. So in this case, we need map error all because we need to have access to the entire non-empty list of errors. So if you want, map error all will give us access to the form errors here. And within this, we need to return a non-empty list of E2. So this means that we need to return that, and we need to wrap this inside a non-empty list. Yeah? So it should be the same. Let's run the test to see if it works. So it really depends on what you prefer. Map error and map error all are quite convenient. But sometimes, you know, doing just a simple pattern matching is also very simple and easy to understand. So really up to you. In summary, today we discovered 2 new types that are not part of the standard library: validation and non-empty list. Non-empty list is like list, except that it must contain at least one element. We'll see in the next couple of videos that non-empty list is very useful in domain modeling. And validation is like either, except that it can store multiple errors and accumulate these errors when we combine validations using zip and zipwith. We just need to remember that for comprehensions always stop at the first failure. This is true for all data types, including option, either, IO, and even validation. Now, we could have taken another approach to accumulate errors. Instead of creating a class, validation, we could have defined it as a type alias for either when the left-hand side is a non-empty list. Then zip and zipwith would be defined as extension methods for this type alias. Both approaches are suitable and available in the CATS FP library. I encourage you to try both to see which one you prefer. That's it for today. I hope you enjoyed this video, and next time we'll work on the end of course project. See you soon!